So we're going to go over some practice problems over 7.2. So in our first problem, we have that in a large population, 55% of the people get a physical examination at least once every 2 years. An SRS of 100 people are interviewed and the sample proportion is computed. The mean and standard deviation of the sampling distribution of the sample proportion are. So because we know that we have a normal distribution, I don't have to check some of the stuff I would normally do. So remember, the mean of our sample proportion is equal to the parameter, which in this case is 0.55. And then our standard deviation is the square root of p, 0.55, times 1 minus p, which is 0.45, over our sample size n, which is 100. So plugging that into a calculator, we get 0.0497. So the answer is D. Okay. Next problem. A survey conducted by Black Flag asked whether or not the action of a certain type of roach disc was effective in killing roaches. 79% of the respondents agreed that the roach disc was effective. The number 79% is A. So because this was a survey and people could choose whether or not they would respond, it is a statistic. All right, unless we're told that every person responded to the survey, we can't say it's a parameter. The variability of a statistic is described by either the spread of its sampling distribution, the amount of bias, the vagueness in the wording of the question used to collect the sample data, probability calculations, or the stability of the population it describes. So this comes directly from the definition of variability, and it comes from A, the spread of the sampling distributions. Remember, less variability means that there is less spread in the data. So that means the more sampling variability you have, the smaller the spread. According to a recent poll, 27% of Americans get 30 minutes of exercise at least 5 days each week. Let's assume that this is the parameter value for the population. If an SRS of size n equals 50 were taken, what is the approximate probability that p hat, the proportion who exercise at least 5 days per week, is higher than 0.30? So we know that our mean of our sample proportion is going to be equal to 0.27. We calculate our standard deviation, and we use 0.27 times 0.73 all over our sample size, 50. Okay, so we do the square root of 0.27 times 0.73 over 50, and we get that our standard deviation is 0.0628. So we're now going to go into our calculator, and we're going to go to normal CDF. Because we're looking to be higher than 0.30, our lower bound is going to be the 0.30. Our upper is our 9s. We'll have our mean of 0.27 and our newly calculated standard deviation 0.0628. And we get 0.3164, which is E. Dane fails to study for his statistics final. The final has 100 multiple choice questions, each with 5 choices. Assume all questions are independent. Dane has no choice but to randomly guess on all 100 questions. So we want to fill in our appropriate numbers. So our first is our sample size n, and that's going to be our 100. Our parameter, because each question has 5 choices, there's a 1 in 5 chance of getting right, is 0.2. So next we want to know, is the sampling distribution approximately normal? Why or why not? So in order to check if a sampling distribution is normal, we check that NP is greater than or equal to 10 and N times 1 minus P is greater than or equal to 10. So we do 100 times 0.2, which is 20, which is greater than or equal to 10. And then we'll do 100 times 0.8, which is 80, which is also greater than or equal to 10. So yes, the sampling distribution is approximately normal. Using the same example, so I'm going to rewrite my information at the top. N is 100, P is 0.2. We want to know, is it unbiased? Why or why not? If it is unbiased, what is the center of the sampling distribution? So remember, the key thing when looking for whether or not a sampling distribution is unbiased is to make sure that it's random. So as long as you're taking a random sample or you are randomly choosing questions, it's unbiased. And because Dane randomly guesses on each question, we can say it is unbiased. So each question randomly guessed, which means the mean of our sampling proportion is equal to our parameter, which is 0.2. Next, we want to know if we have to check the 10% condition here, why or why not. So typically we check the 10% condition if we're looking at a sample of our population. And because in this case, we are talking about all 100 questions on the test and not a sample of a specific number, we don't have to check it here. We just have to make sure that the trials are independent of each other, and it is stated that way. So no, because trials are independent. So next we're going to calculate the standard deviation of our sampling proportion. Just the square root of P, 0.2, times 1 minus P, which is 0.8, all over N, which is 100. And we get 0.04. So putting this all together, we want to know the probability that Dane will get at least a 30% on the test. So a probability statement is that X is greater, P hat is greater than or equal to 0.3. So in our sampling distribution, a mean of 0.2, 0.3, and we're looking to be above it. So we'll use normal CDF. Our lower bound will be 0.3. Our upper bound will be our 9s. Our mean is 0.2, and our standard deviation is 0.04. So we get that the probability he gets at least a 30% is 0.0062. So there is less than a 1% chance that they will get at least a 30% on the test. So not very good. So next we have that one way of checking the effect of undercoverage, such as non-response and other sources of error in a sample survey, is to compare the sample with known facts about the population. So we know about 12% of American adults are Black, and the proportion of Blacks in our SRS of 1,500 adults should therefore be close to 12%. It is unlikely to be exactly 12% because of sampling variability. If a national sample only contains 9.2% Blacks, should we suspect the sampling procedure is somehow underrepresenting Blacks, show your work using the 4-step process. Okay. So we are trying to determine if the proportion of Blacks is actually less than or equal to 0.092. Because in our sample, we only get 9.2%. We have an N of 1,500, and we have a P of 0.12. Okay. So next we just have to check our 3 conditions: random, independent, and normal. So it does state that we are taking an SRS. So it is normal. For independence, we just need to make sure that if we do 1,500 times 10, which is 15,000, that accounts for at least all American adults. And there are more than 15,000 American adults. So it is also independent. Sorry, I wrote normal first and it should be random. Sorry, we're talking about randomness first. And the last test is if it's normal. So 1,500 times 0.12 should be greater than or equal to 10, and 1,500 times 0.88 should be greater than or equal to 10. Okay. So 1,500 times 0.12 is 180, and 1,500 times 0.88 is 1,320. So both of them are greater than or equal to 10. So we're good there, which means we can go ahead and move on to calculating our probability. So in our normal distribution, we have a mean of 0.092. Sorry, not a mean of 0.092. Our mean is 0.12, and we're checking to see if it's actually less than or equal to 0.092. So using normal CDF, our lower bound is going to be -9s because we're doing less than. Our upper is 0.092. Our mean is 0.12. And I forgot to calculate the standard deviation. So the standard deviation is the square root of 0.12 times 0.88 all over 1,500. All underneath the square root. And we get 0.0084. So we go ahead and plug that in. We get the probability is 0.0004. So that tells me that because our probability is so low, it's unlikely that the procedure is underrepresenting Americans. So because the probability is 0.0004 and is very low, it is unlikely to underrepresent African Americans. Point. Our last example says that a USA Today poll asked a random sample of 1,012 US adults what they do with the milk in the bowl after they have eaten the cereal. Of this respondents, 67% said they drink it. Suppose that 70% of US adults actually drink cereal milk. So we want to find the mean and standard deviation of the proportion of the sample that say they drink the milk. So our mean of our sample is going to match our population, which is 0.7. And our standard deviation is going to be 0.73 all over 1,012. And we are going to get 0.0225. Ooh, I typed that wrong in my calculator. Sorry. It's actually 0.0144. Okay. Explain why you can use the formula for the standard deviation in this setting. So remember, that's when we check to see that our sample size is less than or equal to 10% of n, which is our population size. So in this case, 1,012 is less than 10% of all U.S. adults. Or in other words, you can think of there's at least 10,120 U.S. adults. Check that you can use the normal approximation for the distribution of p hat. So that's np greater than or equal to 10 and n times 1 minus p greater than or equal to 10. So 1,012 times 0.7 and 1,012 times 0.3. Both have to be greater than or equal to 10. So 1,012 times 0.7 is 708.4. So that one's met. And 1,012 times 0.3 is 303.6. So also greater than or equal to 10. Next, we want to find the probability of obtaining a sample of 1,012 adults in which 67% or fewer say that they drink the cereal milk. So we're finding the probability that p hat is less than or equal to 0.67. So we know 0.7 is our mean, here's 0.67, and we want to be below. So using normal CDF, our lower bound is our -9s, our upper bound is 0.67, our mean is 0.7, and our standard deviation is 0.0144. And we get that the probability is 0.0186. So almost 2% we can say drink this less than 67% of the cereal milk. Okay. What sample size would be required to reduce the standard deviation of the sample proportion to 1/2 the value you found in part A? So what we're trying to do is find a sample size that would give us half of our standard deviation of 0.0144. So if we take 0.0144 and divide it by 2, we're looking for an n that results in a standard deviation of 0.0072. So what we can do is use our standard deviation formula and our proportion and back solve for a sample size. So I have 0.0072 equals the square root of 0.7 times 0.3 all over n. So the first thing we're going to do is square both sides because we want to get rid of that square root. Okay. And we're going to get 0.00005184 equals 0.7 times 0.3 all over n. So what I'm going to do is set this up as a fraction so I can cross multiply. So 0.7 times 0.3 is 0.21 equals the 0.00005184n. And then I'm going to divide by 0.00005184. And we get that we have to have a sample size of at least 4,051. Okay. It is important here. So our decimal was 4,050.9. So even if my decimal had been 0.4, I still would have rounded up to 4,051 because we want to make sure, because if I round down and I plug it in, I actually won't get a standard deviation of 0.0072. Because we want to make sure that we're getting at least a minimum the standard deviation we're looking for. If I use 4,050, I'll get a standard deviation that is slightly smaller than 0.0072. 4,051 might be slightly bigger, but it's a better representation than if I used 4,050. Lastly, we want to find the probability that in a sample of 1,012 adults, between 69% and 71% say they drink the cereal milk. So that's that our p hat is between 0.69 and 0.71. So we're going to go back to normal CDF. Our lower bound is going to be 0.69. Our upper bound is going to be 0.71. Our mean is 0.7. And we're going to go back to our original standard deviation, 0.0144. And we're going to get 0.5126. So a little over 50% of there's a little over 50% probability that between 69 and 71% say they drink the cereal milk. I would definitely make sure that when you're plugging these values into the calculator, you arrive at the same results I did and try all of these problems independently to make sure you are understanding the material, especially since we'll be working on assignments the next few days and you want to make sure you understand it. So please ask if you have any questions.